Hey, this is Mr. Drogemeyer. Thanks for joining me for our Algebra 1 lesson videos. Today we are in Unit 2, looking at lessons 16 and 17, called Polynomial Identities. And what we want to look at here is we can see some patterns that allow us to factor some of these special cases. So we talked about two special cases, the difference of squares and the perfect square trinomial. Let's start with that difference of squares. And if you remember, we said that it's going to be in the form of a squared minus b squared. So I have a few examples here. We talked about if we have x squared minus 25, that that's a difference of squares. It's going to factor to x plus 5 times x minus 5. Well, what we notice here is that if we take the square root of x squared, that gives us positive or negative x, our x here. If we take the square root of 25, that gives us the positive and negative 5. 5 squared is 25. Negative 5 squared is 25. So notice how we get those values. Same thing with this second example, 9x squared minus 16. What we learned in a previous lesson, it's going to factor to 3x plus 4, 3x minus 4 in that difference of squares. But we can also see when I take the square root of 9x squared, I get positive or negative 3x. When I take the square root of 16, I get positive or negative 4. So you see those values that end up being inside of our parentheses here. Well, what if we have a polynomial like this that is not a difference of squares? Well, we can use this same idea where we're taking the square root to help us figure that out. So in this case, the square root of 5x squared, that's going to be our a term here in our a squared. And then the square root of 29, that's going to be our b term. And so by figuring out what those are, well, the square root, the square root of 5x squared, I could simplify that down because the square root of x squared is x. So actually my a term would be the square root of 5 times x. So let me fix that here real quick. So when I take the square root of 5x squared, I get the square root of 5 times x. And so doing this allows me then to write my factored form. I have the square root of 5 times x plus the square root of 29 and the square root of 5 times x minus the square root of 29. And so that would be the factored form if we were going to factor this difference, the 5x squared minus 29. So just showing you how that property or that identity that we see in that difference of squares can be applied to other situations. We also have an identity that works with perfect square trinomials. And remember, we said a perfect square trinomial is any trinomial that can be factored into two identical binomials. And so we have two different situations here. If we have two binomials, ax plus b, if that ax plus b is squared, we know that it's going to give us, or we could simplify it into this trinomial, a squared x squared plus 2abx plus b squared. And so in looking at our example here, so if I have 3x plus 7 squared, the A term is 3, the B term is 7. Using this identity, I know that it's going to end up simplifying to a squared, which is 3 squared, times x squared, plus 2 times a times b times x, and then plus b squared, which is 7 squared. So if we simplify this, 3 squared is 9, so that's 9x squared. 2 times 3 is 6. 6 times 7 is 42, so this becomes 42x. And then 7 squared is 49. So according to this identity, we could figure out that 3x plus 7 squared is going to equal this 9x squared plus 42x plus 49. Well, what you can kind of see here is that, well, if I can figure out the first term pretty easily. That's just going to be 9x squared. The last term is going to be that 7 squared. That middle term, I just need to multiply the coefficients, the 3 and the 7 times 2, and that's going to give me that middle term. We can go the other direction here as well. If we look at this example that I have here, 16x squared plus 48x plus 36. Here we're going the opposite direction. The square root of 16 is 4. So 4 is going to be my value for A. The square root of 36 is 6. That's going to be my value for B. And then that 48x in the middle, I know that that's got to come from 2 times A times B. Well, 4 times 6 is 24. 24 times 2 gives me that 48. And so knowing how that works, that tells me that this is going to be 4x squared, or excuse me, 4x plus 6 squared, quantity squared. Got a little ahead of myself there. 4x plus 6 and that quantity squared. Because when I take 4x times 4x, I get the 16x squared. 6 times 6 gives me the 36. And then 2 times 4 times 6 gives me that 48 in the middle. All right, so again, just patterns that develop in these special cases. And then our last few examples here, same idea, but now with an ax minus b quantity squared example. So 5x times, or 5x minus 3 squared. So our a term here is 5. Our b term is 3. Looking at our identity here, so 5 squared is 25. So this is going to be 25x squared. We're going to have negative 2 times the a times the b times x. So negative 2 times 5 is negative 10. Negative 10 times 3 is negative 30. So this is negative 30x. And then b squared, 3 squared is 9. And so that's going to be the trinomial form. We can go the opposite direction again. Same idea here. My a term is going to be the square root of 9, which is 3. My b term is going to be the square root of 81, which is 9. And then knowing that, that's going to be 3x minus 9 inside, and that quantity squared. So 3 squared, 3x times 3x is 9x squared. Negative 9 times negative 9 is positive 81. And then negative 2 times 3 times 9 gives me that negative 54 in the middle. All right, and that's all I've got for you today on polynomial identities. Appreciate you taking the time to watch. As always, if you do have questions, please let me know. Thanks. Have a great day.